already? Okay. So just to confirm, yes, Joanna. Oh, sorry. Okay, so this is cancellation, huh? Oh, okay. I thought it's your signature. Email's only 18 orders. Yeah. What is the student revision notes? Oh yeah, sorry, I forgot. Yeah. It's a very small booklet. It's a summary of the whole syllabus one. Yeah. So there's a work example, very little one. Yeah. Sorry. You can. There's no questions inside. Yeah. So even if there are questions, it's just very simple questions. Yeah. It's not PSU level kind of questions. Yeah. Maybe I bring one to show you all. I don't get a chance to see it. Never mind, I take a photo of it. Okay, or I send it to WhatsApp group. Yeah. Okay. Emacs orders no more. How come only 18? How many? 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. I got 18 for Emacs orders. No more, is it? Then Amex I got 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. 18 also, but I got 20 of you. Anyone not order Amex NS series? You don't need? Oh, okay, 10. Then anybody else? 18, 19, so one more person, right? Who else didn't order? You all 3 ordered, right? Okay. Then, everyone here, right? Is it Aya? Oh, it's her. Okay, never mind, ask her later. Okay, anyway, I'll send a photo of it and send it to our WhatsApp group later on after class, just to confirm. Yeah? Oh, okay, sure. Oh, okay. Okay, let's take out your homework. We'll run through the homework first. Okay. Any problems doing question 7? 7? No? Okay. 11? Question 11? 11? Is it? Okay. 11B specifically, okay, sure. Then 13? 13, okay. 23? 23, okay. 25, alright. And 26, okay. When do you manage to do the homework? Huh? You never read. When can I have it? Okay. Alright, question 11. Exercise 8.1. Anyway, I just uploaded the video onto the YouTube, so what it means you please go and catch up on your own. Okay, 11B, yeah. Okay, 11B wants us to find equations of the vertical tangents to the circle x squared plus y squared plus 4x minus 6y equals to 26. Find equation of vertical tangents. Okay. So just now you said you managed to do 11A. Okay. So what can? Oh, okay. So what equation is infinite? What is the equation equation for a vertical line, does it obey y equals mx plus c? You sure? Vertical line, what should the equation be like? X equals to something, right? X equals to a value. So with that, will you know how to do? You sure? Okay. Will anybody else still have trouble with 11b? No, huh? Okay. If that's the case, then I'll move out of 11b. I'll look at question 23 now. Okay, 23, a diagram is given. And then we have a point B in 0. And then A17, C. Okay. So in the diagram, the circle with center C passes through the point A. Okay, and touches the line here at the point 80. In part I, we want to find the equation of the line BC. Okay, so finding the equation of the line BC, BC refers to this radius over here. Okay, so since it's a line, we need the gradient, we need the y-intercept, or at least we need 1 point. Okay, so the crucial thing is find gradient, find 1 point. Okay. Alright, are we able to do question 23? Is this an issue? Just now those who raise hand. Is question 23 part I an issue? No, okay. Then could I skip through the process? Alright, so I'll skip through that. Then by right, your equation should be 4y equals to negative 3x plus 24. What about part 2? Is part 2 an issue? Yes, okay. Alright, so part 2, we want to find the coordinates of C. Okay, so to find the coordinates of C, okay, the thing is that we don't have much information, okay, about the circle itself because there's no equation. So because there's no equation of the circle, we can't work with that to actually figure out the center. However, okay, if you look carefully at the question, they gave you this particular point A, right? Why would we need that A to be given in this question since we didn't even use it in part I? So maybe we need to use that in part 2. Okay? So if you think about it, A to C is a radius. Likewise, B to C is also a radius. What can we conclude about these two radius? They will be. What can you conclude about these two radius? About the value, or maybe about I don't know, the relationship that they could have? Any ideas? Anya? They will be equal, right? Okay, they will be equal. So because they will be equal, okay, then alright, we can figure out, okay, certain equation or expression for the length of AC and also the length of BC, and then we equate them. If we let the coordinates of C be something, so that could be one way for us to start. Okay, so when I let coordinates of C be, let's say, x coordinate is A, what do you think the y coordinate could be? We realize that BC already obeys this certain equation. Okay, or in fact, some of you may not have left it in this form. You may have left it in this form. That's fine as well. Okay, so C is actually found on this line, so it must satisfy this equation. That means that the y coordinate, okay, would be when x is equals to A. So that means the coordinates of C will be negative 3 over 4A plus 6. Okay? Okay. Then now we go about making use of the fact that radius will have to be of the same length, so AC is equals to BC. So now we proceed with the length formula. Okay. Then, although both sides are having square root, we can always square both sides and remove that. So then we could expand. So this will give us 7 plus 3 quarter 8 minus 6. Over 16. Okay, so expand and then after that you simplify it. Notice that you can cancel the a squared. Then cancel this one as well. Minus 2a plus 3 over 2a. Alright. Okay, so the coordinates of C will be at 4, 3. Sorry? You use another method. What other method do you use? Perpendicular bisector. Oh, you find AB, midpoint of AB. But that doesn't always work, right? Yeah, it's just pure coincidence that you got it. Midpoint of AB does not net to this, right? 23 part 2. Oh, okay. Yeah, it's the same. I also did it like that. Then we also find the frequency gradient of AB. Oh, you assume that you take it as a chord. Midpoint of AB, equation of AB. Let's see. Yes. 1 hour 20 lah. Where got 1 hour 40? You won't die, I also will die. Let's see. What's this about? Let's see what does this FC mean. Equation of AB. You equate it with the BC. Oh, okay. But this is direct equation of AD. You're trying to, you said it should be perpendicular bisector of AB, right? Okay? And, yeah, yeah. Okay, so maybe I just briefly say what Joanne did, right, which also works, okay? So what she did was that, okay, you see if I have a point A over here and a point B, let's say over here, and I have this tangent across, which is the original diagram, okay? So what she did was that since you know the point of point of B and also the point 17 of A, recognize that AB is a chord. You cannot assume that it is a diameter. Okay, so no way you can say that the midpoint of AB will be the center C. Right? So you need to definitely recognize it in the general case that it is a chord first. Then after that, because it is a chord, understanding perpendicular bisector of chord. Okay. The thing about this property is that having a chord and then having a line that comes out from the center to that chord, okay, it will always cut at the midpoint. Alright? Then after that, you can find out what is the equation of the perpendicular bisector. Since you will be able to find gradient of this, you can find midpoint, okay, and then you can determine the gradient of this perpendicular bisector, and then subsequently the equation of this perpendicular bisector. So having this equation of perpendicular bisector, and earlier on you had the equation of BC, okay, from part I. So you can find the intersection point between the radius as well as this perpendicular bisector. You understand what I'm saying? Okay, so that is a possible method as well. Right? I'm sharing that method because you need to be familiar with more methods, right? Rather than sticking to one, because sometimes there's really a wide range of possible questions. So even myself, I cannot classify the different questions that are available. So that was one skill that we also learned earlier, where we look for intersection points, okay, of two lines for the coordinate for the point that we want. Okay. All right. Then let's look at part 3. I believe it shouldn't be an issue anymore, right? Because now that we have found the point of the center, then you know the radius length. Okay, so finding the equation of the entire circle, I hope is not an issue. Okay. Now, I'll look at 25. Could I erase this side? Okay. Okay. For question 25, right? They asked in the first part, how are the coordinates of the center of C related? Do you know the answer? What would it be, Emily? A and B are equal. Okay, sure you can let A and B be the coordinates of the center. Otherwise, you can just say that the x coordinate is equal to the y coordinate. Okay, because the negative x and y axis are tangents to the circle. So earlier on, I think I gave you a question before that if the axes are the tangents, surely the distance here and the distance here will have to be the same since they will mark out the radii. That's why the coordinates here, okay, will actually have to be equal. So x coordinate is equal to y coordinate. Okay. Then after that, moving on to the next part of the question, it says that the line L is the tangent to C at the point P negative 8, negative 9. So, sorry, I draw it wrongly, right? Sorry, my bad. It's like that. Right? Okay. So we have negative 8, negative 9, let's say it's around here. And then we have a tangent. This is a line L. Center of C lies above and to the right. Okay, how I know that this will have to be the case because it says the center is above and to the right of P. So center is here. We want to find the equation of C. Okay, sorry. Center is not labeled as C, but the entire circle is labeled as C. Okay, so to find the equation of the circle, we need to determine the coordinates of the center as well as the radius. So what you could do is that since you know that x coordinate and y coordinate will be equal, okay, depending on your personal preference, whether how you want to define this this coordinate of the center itself, what we can do is to let the center of the circle be k and k, alright? That's one way, but the thing is that this condition for k will be that it must be less than 0. Okay. Otherwise, okay, you have tendency to maybe forget that your coordinate will have to be negative. Then you can put negative k, negative k. Then k will have to be more than 0. You understand what I'm saying? Because of the negative sign over there. So up to your personal preference, okay. What I have already done was to actually do positive looking k, but k value itself is actually negative. Okay, so I'll just continue with this, right? So that means that the radius of circle, okay, is actually this length over here, which goes by the coordinate. But taking note that because my k is less than 0, radius has to be radius has to be positive. So we will have negative k as the radius of circle. You follow what I'm saying? Because k itself is negative, you need to put in another negative sign to ensure the radius is positive. Okay? So then from here, hang on now, what equation of circle radius? Okay, so therefore, okay, let me adjust diagram. Down here is k and k. Okay, so what we can do is that we form an equation to determine the value of k, because what we need here is to know what is the center. With knowing the center value, okay, or rather the radius, the value of k itself, it will resolve everything for us. Okay, once you know the value of k, you will know the radius, you will know the center. Okay, so to determine the value of k itself, we know that this will be the radius, that value will be negative k, and this length itself, we can make use of the length formula to form an expression out of it. Okay, so we have k plus 8 squared plus k plus 9 squared. That will be equals to negative k. Okay? Then after that, we can square both sides, you will get k squared here. That will get rid of the negative sign there. Expand this. Then we solve to find that the value of k will be negative 29 or negative 5. But the problem is both are negative. And we did want our k to be negative. So then how do we choose and reject? Under what condition do we reject? What do you think? How? If you go back to the question and look at it carefully, what is it about the center C? It must be top and to the right? Okay, so can we have our k value to be negative 29 for these values here? Can we have x to be negative 29? We can't, right? Because over here our x coordinate is already negative 8. For this to be at the top and towards the right, that means that my value of k must be greater than negative 8. Okay, and negative 29 is lesser than negative 8. So therefore, we reject our k equals to negative 29. Okay, so if you need to have the reason. So therefore, this will tell us that the center is at negative 5, and the radius is 5 units. Then equation of circle will be x plus 5 squared plus y plus 5 squared equals 25. So you managed to do this question. Okay, then part 3 we want to find the equation of L. How could we find the equation of L? It's a straight line, so we need gradient in one point. Point is given already. How could we find the gradient of L? How to find? Chloe, suggestion? How could we find the gradient of this line? Find the gradient of CP. Okay, so assuming I think you mentioned you are thinking that C is the center, but take note that notation-wise, the question defines C to be the circle itself. It is not defined for the center. So to make things neater, is this part 3? Okay, so we let center of circle we have. Okay, so as Chloe suggests, we find the gradient of FE. That will be negative 5 plus 9 over negative 5 plus 8. So 4 over 3. And the gradient of the line L would be what's the gradient of the line L? With the gradient of the line L. Sorry? Negative 3 over 4, good. So equation of L can be found with y minus plus 9 equals to negative 3 over 4 x plus 8. Okay. I will not complete it. Please simplify that on your own. Any questions? Okay, now let's look at question 26. Okay, the question 26 part I, would there be any problem for 26 part I? I hope not, right? Okay, so you should be able to get the center, which is 5, negative 2, and the radius 3 units. Okay, so let's say if this one is the circle C1, we will have 5, negative 2, radius 3 units. Okay, then after in the next part of the question, it says that the coordinates of the center of the second circle is negative 2, 3. Okay, so there's a second circle. Okay, then this is not relative, I'm just drawing it separately. Okay, the equation of the tangent to C2 at the point P, okay, is that it is y minus 2x equals to 17. So this will be point P. Okay, and we want to find the coordinates of P. How could we find the coordinates of P then? Are you able to do part 2? Is there an issue with part 2? No? Okay. So, no, that means I can move on. Is it? Okay. Then what's the issue in question 26? What's the issue? The part 4. Okay. Part 4, it asks, determine whether C1 and C2 intersect each other. Show your method clearly. Okay, so how will two circles look like if they intersect each other? Okay, then I'll erase this one. Okay, you see if they intersect each other, right? Okay, so we have two centers here. Okay, one is at 5, negative 2. Let's say this one 5, negative 2. The other one is at where? Equation of P to center. What's the coordinates of the second center? Negative 2, 3. Okay, so if they intersect each other, this is an intersection, right? Okay, what would the length of this, the distance between the two centers be like? Okay, the distance between the two centers, should it be equal to the sum of the two radius? Okay, or should it be lesser than the sum of the two radius, or would it be more than the sum of the two radius? So we're looking at sum of the two radius, or rather two radii. Okay, so would it be more than, equals to, or less than for the distance between the two centers? What do you think? Who would think that it's more than if we intersect? Who thinks it will be equals to? Who thinks it will be lesser than? Okay, actually the correct answer is it could be equals to or less than. Because intersect, even if they touch each other at one point, is considered intersection also. Okay, so what we can do is to determine the distance between the two centers. Okay, so if they do not intersect, how will it be like? If they do not intersect, it will be far apart, right? Then the distance between the two centers will be more than the sum of the two radii. You understand what I'm saying? So go and find the distance between the two centers, which is to take the length of line segment of these two coordinates, compare it to the sum of the two radii, and the sum of the two radii would be equals to 3 plus square root 20. Okay, because square root 20 is the radii of the second circle. You understand what I'm saying? Okay, so will you be able to do that now? Okay, I want you to be able to write it out on your own rather than you copying. Okay, so if you understand, you can definitely write it out. Okay, I'll give you 5 minutes to complete that part before you submit it to the front. Then I'll go to try 10. Okay, I know you all probably didn't have your textbook, which I told you not to bring, right? So the essential, necessary information, I wrote it on the whiteboard. Can do. Okay, when you're ready, pass your homework to the front, please. So conclusion by right is that they do not intersect. Yeah? Conclusion should be that they do not intersect. The distance that you find would have been greater than the sum of the two radii. What do you understand already?
find is to find this individually. Use the formula. Find out the number. Then sum of two radii is 3 plus 4. Press out calculator decimal. Open decimal. Then see that this one equal to 10. Okay. Submit to the front, please. You want to you go home do it or you do yourself without class, and that will improve yourself. I never write the answer yet.
What do you mean? Who else Let's look at the final question for our circles. Try 10. Okay, it says that we want to find the equations of the tangents to the circle. Circle has this particular equation here, so let's draw out a circle. Okay, with this equation. Okay, and these tangents are perpendicular to a certain line x plus y equals to 1. This line, the question didn't say where is this line, whether it intersects the circle or not. Okay, so what we can do is just draw a random line. I drew a downward sloping one because I will see that if I have the x shifted to the other side, it will become negative x, so the gradient will be negative. Okay, then it says that the tangent is perpendicular to this line, so you can have a tangent perpendicular and another tangent perpendicular. Technically, who can conclude about these two tangents? They will have to be what? Parallel, yeah? Okay, I label tangent 1, tangent 2. So your diagram will have to look like this. Okay? So we want to find the equation of the tangent. Likewise, okay, tangent is a straight line. You need to find gradient. You need to find one point. Okay? So the issue here is, can we find the gradient? Are we able to determine the gradient of the tangent? We know the we know the equation of this random line, right? So can we find gradient of the tangent? Yes, right? Okay, so let's do that first. Okay, so we have x plus y equals to 1. So gradient of this gradient is equal to -1. So gradient of tangents would have been equal to, what's the gradient of the tangents? It will be +1, yeah? Okay, following so far? Right? The next thing is that, okay, we need 1 point. So, since we needed gradient, we also need 1 point on each tangent somehow. So I need to know this point here, and we need to know this point here. But the problem is that, okay, I don't have any information about these 2 points. Even if I go and find out what is the center of this circle over here, knowing the center itself doesn't quite help us in finding out these lines. Because we don't have the information about the tangent in the first place. Okay, so what can we do then? Right, and this is the biggest problem about this question. Okay, so what we can do is that, alright, don't need to think about the point part. Okay, we know that tangent is a straight line, it must obey y equals to mx plus c. We know the gradient. Let's just use the c as something that we don't know yet. Let it be arbitrary. Okay, meaning to say let it be an unknown. Okay, so let's the equation of tangents be equations of tangents actually. Okay, be y equals to gradient we know is 1, so x plus c. Okay. Because this c is going to just be 2 numbers. Okay, one is for this tangent 1, the other one will be tangent 2. Right? So the thing about these tangents is that it is intersecting the circle. You agree? The tangent will intersect at the circle, okay, at 1 point each. Okay, so since they intersect, we make them intersect by making them equal to each other. So equation 1, equation 2, we sub 1 into 2. And then, even if you do this, you realize you're still very much stuck. Most likely now. Okay? And that's why my role is to be doing here. Okay? So what can we do next? Right? We looked at a line. Okay? So this is a line. This is a circle, which is technically a curve as well. Agree? Okay? And this curve, okay, is it linear, quadratic, cubic? What would it be? It is kind of quadratic, right? And somehow we're talking about tangents. The thing about tangent is that when we learned our very first 2 chapters of A Maths last year, okay, tangents meet a curve at how many points? 1 point. Okay. Since it meets at 1 point, what will the discriminant be? Discriminant is what? Discriminant is what is 0? Equal, less than, more than? Equals to 0, right? Okay. So meet at 1 point, discriminant equals to 0. What exactly is discriminant again? Okay, b squared minus 4ac, right? So we find the b squared minus 4ac. So b is our 2c. A is our 2. C is the c squared minus 4. Okay, and that will be equals to 0. And we find that C is square root 8 or negative square root 8. Okay, you may want to simplify that cert, that's fine as well. You will get 2 square root 2. Okay, so that is the approach that we will have in terms of finding the value of C. Okay, then after that, we can find out what is the equation of the tangent. So equations of tangents are y equals to x plus 2 square root 2 and y equals to x minus 2 square root 2. Okay. Right? This is definitely, I think, the most challenging question in all your circles question out of all the try examples. Okay, because it overlaps with your other topics. I will say that when you practice your circles, right? Okay, do the simpler ones first. Okay, do the manageable ones that we have been looking at. That means those that involve our tangent perpendicular to radius property or perpendicular bisector. Okay, property. Alright, so work on that first before you jump into this kind of. Okay, in fact, most of the questions that you see will most likely be those kinds rather than such a kind of. Okay. Any questions? And if not, okay, then we close up our chapter 8 and we are done with our volume A book. Okay. Then we can now move on to our volume B book, which is much cleaner. Okay, but thin things may not mean that they are easy, so it's a matter of how we digest it. Okay, but I hope that by printing for you, the formula book is slightly easier for you. Okay, so if you have your formula book with you, we will be